I'd like to thank the Southeast Pavement Preservation Partnership for inviting me here today, and also thank Zach and Patty for the wonderful work they do behind the scenes to keep us out of trouble, despite some of your best efforts. So, how many of you thought that presentation that was just introduced is a single presentation? Anybody? I was a little confused myself. It's actually two different titles, I think. I hope that was the intention. There's two separate topics here. And so I'm going to take liberties from the podium here to present them in the order that I'd like to. And I'm starting with a presentation that's based on work that my colleague Greg Duncan did for FHWA, a study on the use of RAP in surface treatments. So Greg could not be here today, and Greg really has a lot of the background, and a lot of this presentation comes from a webinar that he did to present the project information. So some of you may have seen some of this already. So please bear with me, and please consider me to not be the expert on this topic when it comes to questions at the end. So thank you in advance. A little bit of background on the project. This highlights what we were trying to accomplish with this project, and it was an FHWA-funded project that whose purpose was to look at the use of RAP in preservation surface treatment. So everybody's familiar with the use of recycled asphalt pavement in hot mix pavement, but you may not be as familiar with its use in pavement preservation treatments. At the same time, this has been going on for a number of years. The FHWA was interested in getting word on this and some of the experiences out to the rest of the pavement community. So the study focused on the experiences of those agencies and organizations that are using RAP and what they've learned from that, and specifically focusing on chip seals, microsurfacing, and slurry seals that use RAP, and provide guidance for practitioners who perhaps aren't using it to move forward and make that decision. Some characteristics of recycled asphalt pavement. I think we all recognize that it's a product that has value. We no longer waste asphalt pavements when we mill it up during rehabilitation or reconstruction. That material is typically stockpiled, and industry wants to get as much of it back into new pavements as possible for a lot of reasons. So it comes with an intrinsic value. It's also a source of high-quality materials. And why is it high-quality materials? It's because that aggregate has already been accepted and approved, has already passed tests on the aggregate, so there's little question that the aggregate and even the binder around the aggregate is a quality material that can be used in pavement surfaces. The material itself behaves as black rock, in other words, coated with asphalt. So there's some benefits to the black rock aspect of it, much the same as you might get from pre-coating virgin aggregate. You also get some interactiveness between the binder coating on that recycled material and the new mix that you're putting down. In terms of the processing, of course, when we're looking at surface treatments, and they're all going to have smaller sized aggregate than most hot mixes. So there's going to be some crushing involved, some processing of that recycled asphalt pavement. And what you end up with, according to experience, is a fractionation in which about 40% is coarse aggregate that can be used in some of the chip seals, and about 60% is fines. And we'll get back to that later on in the presentation. So when the team went to look at how RAP is currently being used, they found very limited practice. And I want to point out that this study started, I think, in about 2016, and the ink was drying on the final report in 2021. But much of the research is closer to 2016, 2017, 2018. And at that time, a lot of the experience with the use of recycled asphalt pavement and surface treatments was coming out of California. I'll give a little information on some of the case study information later on, but there's also some experience in New Mexico and a little bit of experience elsewhere, but there wasn't much published on this topic at the time. Some of the early findings: why use recycled asphalt pavement? And this is just a general statement. The material, the use of the product is cost effective. There's a savings associated with using the stockpiled material. It's environmentally sustainable. There's a number of issues that go into this, and again, when we look at some of the case study information coming up, one of the agencies in particular was very focused on a sustainable pavement program, and the use of RAP fed into that very nicely. And another of the case studies points out how the use of RAP in their chip seal program allowed them to address a shortage of high quality aggregates that they needed. So it was actually meeting a need instead of long haul distances for high quality aggregates. What are some of the differences that you might expect to see when using RAP instead of virgin aggregate in surface treatments? Well, for chip seals in particular, they identified a better aggregate bond than the bond between binder and virgin aggregate, and blacker texture for longer. So the appearance stayed black for longer. Now, just anecdotally and as an aside, looking at some surface treatments on another project, one company told me, a company whose product doesn't stay black for very long, they said, you know, there's nowhere in the specification that says this product has to stay black. The blackness is just a user objective. It provides a benefit, but there's no specification that says we're going to measure blackness and we want it to be black longer. But there is a benefit that's recognized in terms of appearance of pavement markings and just the general visuals. The pavement could look more like a hot mix pavement when it stays black longer. For microsurface and slurry, a couple early findings, and I'll get back to these and probably just repeat them later on. They found that there was a slight reduction in the use of virgin asphalt emulsion and a slower set for the product using recycled materials. As I said, there were a number of case studies that were a part of this project. This NCAT study, and I don't know if, I don't see anybody offhand who's still here from NCAT, but this was just relating experience with the use of a recycled aggregate on a chip seal that they did at the test track in Auburn in 2015, and they put end-to-end a section. Remember, I don't know if you remember, Buzz said these sections are about 200 feet long. They put down a section with pre-coated aggregate and the chip seal, and then a wrap chip seal. And the findings are summarized here on the side of the slide. Not really as much on the use of recycled aggregate in surface treatments as some of the other case studies. The one conclusion that they drew from this is that the wrap section had lower friction after 2 years than the pre-coated virgin section. There's some thoughts about why that occurred in terms of the amount of fines and other material that might have gotten into the mix. But this just shows that it has been studied, it is being studied elsewhere. I don't know if Mike Helmsley is still in the room, but this information comes from Mike. So Greg also did a case study based on Paragon's experience using wrap, and Paragon does mixed designs for clients using for surface treatments, and they have done a fair bit of work on the use of recycled materials in surface treatments. So their findings show that they had similar test results for wrap, slurry, and microsurface in terms of the wet track abrasion and the loaded wheel testers. So indicators of long-term performance showed that they were going to get similar results using the wrap aggregate. And they could develop a design that had lower emulsion content, added emulsion to the wrap-based slurry and micro, while having an overall higher binder content. I pointed out that New Mexico was one of the states that had experience when this project started in the use of wrap and surface treatments. The information that New Mexico provided was based on, as I mentioned, they had scarce sources for high quality aggregate, and they were facing long haul distances for the chip seals that they were placing. In New Mexico, the state retained the wrap piles, and they use in-house crews to place their chip seals. So these conditions may be unique to them, although I know other agencies have variations on this in terms of in-house crews and who owns the wrap material. And what they ended up doing was contracting out for fractionation, for taking the wrap and breaking it down into the chips and the fines, and also contracted out the hauling. So they would have the contractor who further processed the material, distribute it in New Mexico right of way around the state, or I think this was in District 6, around the district, stockpiling it in right of way at strategic locations where the state could pick it up later to use it. Through that process, they generated significant cost savings shown here. So this compares the use of chip seal placed with New Mexico wrap and virgin material. And my understanding is this includes the cost of processing and hauling the aggregate. So a significant cost savings, keeping in mind that they are placing these chip seals using their own crews. Their crews reported a similar application rate for the emulsion and the stone using the wrap material. As I mentioned before, one of the benefits of that wrap in the surface treatment was a darker appearance, since it's already coming pre-coated, if you will. Similar skid resistance, so a little bit different result in New Mexico from what the NCAT study showed in their comparison. And then, one issue that comes up multiple times is the use of the fines. So remember, I mentioned that in the fractionation process, they're generating about 40% coarse aggregate that's used in chip seals and 60% fines. So one of the ongoing challenges is the use of fines, and a place for that, an obvious place, would be in microsurfacing and slurry seals to process that. But they've also used it on shoulders, on base materials mixed with base. So they found places to put it, maybe not at its optimal value, but somewhere where it could be incorporated into the pavement rehabilitation or construction process. The next case study example came from San Bernardino County in California. This, I believe their experience was built on what they learned from Los Angeles County, which is another case study. Again, facing some of the same issues that New Mexico and others were facing in terms of scarce sources for high quality aggregate, also using in-house chip seal crews. And the way they handled construction was they contracted for aggregate delivery. That delivered aggregate, stockpiled aggregate, was then used by their in-house crews to place the chip seals. So they had a bid competition for this, which they felt gave them a pretty good price for those contracts, and they realized a savings of up to 30% by using the recycled aggregate and placing the material with their own crews. Los Angeles County, I think, is the final case study that was used in the report. And Los Angeles County has been a really significant user of recycled aggregate in surface treatments. And their focus was a little bit different when they started. They placed a large emphasis on sustainability. Sustainability involving reuse of scarce resources, coming up with a more environmentally friendly product, shorter haul distances, less acquisition of virgin materials, more reuse of existing materials. And so they specified wrap treatments. Of course, it didn't hurt that they were getting the same performance, as far as they could tell, from the use of wrap in surface treatments that they were getting from the use of virgin aggregates. So they developed a job order contracting mechanism, and just mention here that identifies the treatments that they use as part of their preservation program. This just shows some of one of the infographics that they used, and again, I'll echo many of my fellow presenters in saying, I know you can't read this, and I once made a vow to never show a slide again where I said that, but obviously we break our promises all the time. But you can recognize the typical performance curve. You can recognize summaries of pavement condition, but the main point here about sustainability at the bottom, that last bit of the graphic shows 84% reduction in greenhouse gas emissions, 80% reduction in energy consumption, and 418,000 cubic yard reduction in landfill. So again, they really emphasized sustainable or environmental benefits of wrap use in surface treatments. They have a few before and after pictures, and I'm not sure how much they tell us. This first set shows virgin aggregate as a surface treatment, in this case a slurry and asphalt rubberized chip seal, representing the after condition placed on that pavement that shows the before condition. So that's using their conventional process. And this shows a different road using their wrap slurry as part of the surface treatment, the before and after. And they're not the same road, they're not end-to-end sections, but they are, so this one is 4 years after treatment, this previous one is 6 years after treatment. And I guess you could draw the conclusion that there's really no obvious deficiency or reason why you would say that the wrap-based slurry in this instance is performing any worse than the slurry with virgin material. This is a comparison of the specifications. If you look at the two far columns, the wrap slurry seal requirements and the virgin type 2 slurry seal requirements, and you can look at where there are differences. One is in the amount of emulsion. The next is the amount of residual asphalt. The sand equivalent is a little higher for this wrap material to account for some of the difficulties in processing, I imagine. But you can see overall they're fairly similar. There's not much difference, but there is some difference in how they specify the materials when wrap is used versus when virgin aggregates are used. I lied, there's one more case study. This is from Pavement Coatings, a company in California that launched into the use of wrap probably before almost anyone else in the country. Greg talked to them about their experience, and they set about investigating whether they had access to a lot of wrap, and they investigated whether the use of that wrap was viable in pavement preservation, meaning surface treatments. And they ended up merging. There were two companies that merged once they found that they could find a use for the recycled materials that the one company was producing. The bottom line is that they found they could generate similar performance between their wrap mixes for surface treatments and their virgin mixes. The one thing they did learn, as I mentioned earlier, in the fractionation process is about a 40-60 split between coarse aggregate and fines. The use of the coarse aggregate is pretty obvious. It goes into the chip seals and works quite nicely there. It's more of a challenge to use the fines, and that's shown here in Pavement Coatings' stockpile of fines that they had at their plant. They also, this is a look at some recycled aggregate, and it raises the question of, is that dirty aggregate or is that quality aggregate? And addressing that, the way that's addressed is that they make sure that they limit the fines in the coarse aggregate and run the sand equivalence test to make sure that there's not excessive dust coating that product. Overall findings, I think the point's been emphasized throughout that the recycled material can be a cost-effective alternative to virgin aggregate. In some cases, it depends on who owns the aggregate, and if the agency doesn't own it, can they get a competitive bidding process for the use of wrap versus the use of virgin aggregate? And in some cases, there may not be some available because it goes into hot mix where it generates a better return, but in others it is available. For chip seals, the wrap use required little minor changes and gave comparable performance. For wrap use in slurry and microsurfacing, it required a reduced emulsion content. The final comment there, wrap use in surface treatments is rapidly progressing. In preparing for this, I had seen some articles about the use of wrap, and I did a quick search on the internet. So, in 2016, when this started, most of the experience was in California, as I mentioned. There was a small test section in Auburn and New Mexico's experience. The other day when I searched, I found companies in Alaska and Canada and articles about experience in these states using wrap in surface treatments. Any agencies here tried this? It's a virgin aggregate crowd. All right. You can see the map is being filled in. A lot of it, I think, depends on who owns the wrap and who places it and what sort of price you can get for it. But the practice certainly is spreading and has been shown to be effective. The typical last slide says any questions, but gosh, if there were, I don't know if I could answer them.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.